A car moves along a straight horizontal road from a point A to a point B, where AB equals 885 meters. The car accelerates from rest at A to a speed of 15 meters per second at a constant rate of A meters per second per second. The time for which the car accelerates is t over 3 seconds. The car maintains the speed of 15 meters per second for t seconds. The car then decelerates at a constant rate of 2.5 meters per second, stopping at B. Find the time for which the car decelerates. Sketch a speed time graph for the motion of the car. Find the value of t. Find the value of A. Sketch an acceleration time graph for the motion of the car. Okay, so here's the question in summary form. I've done the picture with all the data contained therein. So let's have a little look at it. We want the time for which the car decelerates first. Here's the deceleration phase in the picture. So let's have a look at part A then, in the picture. The time for which the car decelerates. Well, we got an initial speed of 15, we got a final speed of 0, and then a deceleration of 2.5, or an acceleration of minus 2.5 meters per second. So if we use v equals u plus at, we should be able to find the time, shouldn't we? Gives. So the final velocity is 0. The initial velocity is 15. The acceleration is minus 2.5 times the time which we don't know. So that tells us then that t equals 2.5t, move that over there. So the 15 stays as is. And well, I'll write it out more long-windedly than this on a fresh line. So that tells us then, move the 2.5t over here, is equal to 15, and that tells us that t is equal to 15. Move the 2.5 to divide from times, t is equal to 6 seconds. So there's the time then, 6 seconds for the deceleration phase. So let's put that in the picture. T equals 6. There we go. So now the next part B then, let's have a look at that. Sketch a speed time graph for the car. So let's have a look at that then. Here's the actual data. So let's draw a line, say here. I'll draw it I'm not going to draw it very high because I want to try and get all the information on the page. So I'll do it quite narrow. Okay, so this is the time, and this is the speed. Okay, well it starts at 0 here at time t equals 0, and then it goes up to 15 at time t equals t over 3, and it reaches a speed of 15. And then it carries on that same velocity for t seconds over to here. So if you add t onto t over 3, you get 4t over 3, and it still is at 15 meters per second. Then it decelerates in 6 seconds. So this time here then is 4t over 3 plus 6. And it goes down to 0, stops, comes to rest. So we just need to draw straight line segments. I've got a digital pen, so I'll try my best, and I use dashed lines to draw these straight line segments. Although what I could do, actually I'll try and use a ruler then and see how I get on. So we'll start here with the ruler. I'll go up to here, then straight along here, and then straight down there. So that should be a flat line, shouldn't it? 15 and 15, this should be flat in the sketch, and that's what we've got for our speed time graph. Sketch. So there's B then, so let's mark that in. Okay, part C. Find the time t. So t then, capital T. We've got all the information in the picture, haven't we, here? So C. So we know the total distance is 885. So if we can use the distance function S, in terms of the time. So s equals ut plus half at squared is the formula for all these little segments. We know the acceleration is naught here, and we know the time and the speed. We know the acceleration here, we know the time and the initial speed. So those two segments we can work out the distances. Here we don't know the acceleration, which we need, so let's use v equals u plus at. So let's also use v equals u plus at. These two equations give, so the final velocity here is 15, is equal to the initial velocity here at a, which is 0, plus a, the acceleration, times the time, which was t over 3, wasn't it? If we look back up, see it, t over 3 is the time. So put that in. So v equals u plus acceleration times the time, t over 3. So the acceleration then is equal to, move the 3 up to 45, and move the t down to divide 45 over t. So there's the acceleration. Now we can use s equals gives. So we've got that for reference, and we've got this equation here. So the first distance, ut, 0t, so s is 0 for the first segment will be 0 times t plus half a, 45 over t, times the time, and the time for the first segment we said before was t over 3, half a t squared, plus, now the next segment there's no acceleration, so it's just the ut part of the formula, so 15 times the time, which was t for that section, and then the last segment, put it in a bracket, ut is 15 times the time, which was 6, wasn't it? So that's 15 times 6 plus half a, so it's a half. Acceleration on this last segment was minus 2.5, wasn't it? If we remember, minus 2.5 is the acceleration, times the time, which is 6, close bracket. That total distance then, here, here and here, must add up to the total distance between A and B, which we wrote down as 885. So what have we got then? This will be 9 when we square it. 9 into 45 goes 5. And one of the t's will cancel, so this is 5t over 2. Plus the 15t we can write as 30t over 2, that's 15t. Plus 90. 6 over 2 is 3. Oh, this is half a t squared, sorry, that's t squared. Time is 6 squared, so it's 36 over 2 minus, so it's 36 over 2, which is 18, so it's minus 18, 36 over 2 is 18. This is 5 over 2, isn't it? So I'm going to write it as 5 over 2. Yeah, equals 885. 9, this is 2 goes into 18 9 times, and 9 5s are 45. So this is 5t plus 30 is 35t over 2 is equal to, this is 9 5s are 45, 90 minus 45 is 45. Move that over, 885 minus 45, which is 840. So the only difficult bit here was when we put t squared in, 18 over 2 was 9, but this was, or 18 over 2 here and here, and the 2.5 we wrote as minus 5 over 2. Oh, minus 5 over 2, and 36 over 2 is 18, that's it. And then we worked out that fraction to be 45. Here, 90 minus 45 was 45. and then we moved it over to be minus. So he did a lot of things in a very short time there. I hope you can see that. So this tells us what the time is then. 2 lots of 1840 is 1680 over 35. Times that in the calculator then. 1680 divided by 35 equals 48. So t is 48 seconds. Okay, so that's the time. So this is going to be 48 over 3 is 16. This is 48. T is 48 itself, isn't it? So when you add down 16 you get 64. And this was 6. So that would go up to 70. So here the acceleration was equal to, what was it? 45 over t. And t is 48. 45 over 48. Divide by 3 is 15 over 16. Here a equals 0. And here a equals minus 5 over 2, wasn't it? Or minus 2.5. Yeah. So that's the acceleration then, because the next part of the question now, the final part, find a, which we've done, d, we've done a, above, so let's just write that down. Here, a was equal to, I'll put it in that, here the acceleration was 45 over t, 45 over 48, which equals 15 over 16, and e, and now we just do a little part E, finish it off, sketch the acceleration time graph. So I'll do a little sketch of that just to finish things off. So a quick sketch there then. Here's the time, here's the acceleration, which I'll just write as acceleration. Here's 0, and then the first 15 over 60, the first t over 3 was 16 seconds, wasn't it? So that's 16. Then we added a t to it, we got 48. T was 48 plus 16 is 64 rather. And then we added 6 more and we got 70. The first acceleration, it had the value 15 over 16. So here, this is, I'm going to get negative, so I'm going to put it here then. 15 over 16. 15 over 16. I've done a dashed line because I'm using a digital pen. And then I use a different colour. Uh, 70. Now I use a different colour, sorry. This is the first part here. I'll try and draw a straight line. It's 15 over 16. Then it's 0. So I'm just trying to put that in there to emphasize it. And then it was minus 2.5, wasn't it? So we just need to go along here. And I'll put minus 2.5 here. And I'm going to carry on that line as best I can. Down here. And we would want to sketch it all in yellow, really, in one colour, really, wouldn't we? It's easier on the eye. And there's the acceleration time sketch.